This lecture video is about solving equations using quadratic methods. So there are several types of equations that will end up giving us equations that have a quadratic form, and so that's what we're going to look at today. Our first example is a rational equation. We have 6 over x plus 1 over x minus 3 equals 1. And so the first step always in solving these rational equations is to multiply by the least common denominator. And the least common denominator, we have x in this denominator and x minus 3 in this denominator, so you just would multiply those two together to get your least common denominator. So we're going to multiply each of these terms by the least common denominator. And so when we multiply 6 over x by x times x minus 3, the x's cancel, and we're left with 6 times x minus 3. And here, when you multiply 1 over x minus 3 by x times x minus 3, the x minus 3's cancel, leaving us with plus x. And then it's equal to x times x minus 3. So now before we can solve this, we need to distribute the 6 here and distribute the x here. So this will give us 6x minus 18 plus x equals x squared minus 3x. And now this is a quadratic because we have a squared term here. And I have 6x and x, so that's 7x minus 18 on the left. And it's equal to x squared minus 3x on the right. So we want all of our terms to be on one side of the equation, and I also want my x squared to be positive, so I'm going to have everything over here on the right. So I'm going to subtract 7x and add 18 to both sides. That gives me x squared minus 10x plus 18 equals 0. Now we would want to see if we can factor this. So can I factor 18 so that the sum will give me negative 10? And we can't. 18 factors is 1 times 18, 2 times 9, and 3 times 6. And none of those will give you 10. So that means that we need to use our quadratic formula. So remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have negative 10 as our b, so we'll have positive 10 plus or minus the square root of negative 10 squared minus 4 times a, which is 1, and then times c, which is 18. And then this is all over 2 times a, and a for us is just 1, so that would be 2. So I have 10 plus or minus the square root of 100 minus 4 times 18, so that's 72, all over 2. So we have 10 plus or minus 100 minus 72 is 28. And this is all over 2. And 28 is 4 times 7, so we can simplify that square root. We have 10 plus or minus 2 times the square root of 7 over 2. And then you can factor a 2 out of the top, leaving you with 5 plus or minus square root of 7. And this is all over 2, and then you can cancel these 2's. And so we get 5 plus or minus the square root of 7. Okay. So our next one here, x to the 4th equals 25. So in this one, you should end up with 4 solutions for this because you have a power of 4 for your x. Just like when we had an x squared, we ended up with 2 solutions. 5 plus or minus the square root of 7. So one way to think about this is just taking the square root. So you have x to the 4th equals 25. And so if we take the square root on both sides of that, we're going to get x squared equals plus or minus 5. And so now we have two equations here. We have x squared equals 5, and we have x squared equals negative 5. So we need to figure out what x is. This only gave me x squared, so now to get x, I need to take the square root on both sides again. So this gives you x equals plus or minus 5, and this one gives you x equals plus or minus, and the square root of negative 5, remember, is I times the square root of 5. So we have four solutions. We have positive 5, negative 5, positive I times the square root of 5, and negative I times the square root of 5. In our next example here, so again we have a fourth power, and we have x to the fourth plus 2x squared minus 24 equals 0. So we're missing the cubed power of x, and we're also missing the plain old x term. And so this is really going to make things pretty nice. You can actually just factor this. So we really have x squared being squared here, and then this is x being, we have our x squared term in the middle, and then no x's here. So I'll show you the substitution method, and then I'll also show you how you can do it with just factoring. So we can make this look exactly like a quadratic with a squared term, a non-squared term, and a constant term. I'm going to let the letter t be equal to, and you always pick the letter that's in the middle here, the variable in the middle. So we're going to let that be x squared. So if t equals x squared, then t squared, if you square x squared, you get x to the fourth. And so now we're going to substitute. Let's see here. So, sorry, I put the box around the wrong thing. T squared is equal to x to the fourth. So I'm going to take this t squared, and I'll go underneath with it. And t squared is x to the fourth. So we're going to replace the x to the fourth with t squared. And x squared is equal to t, so instead of x squared, I'm going to write t. So that would be plus 2t minus 24 equals 0. So now this is exactly a quadratic, and we can factor this. It would be t plus 6 times t minus 4. Factoring negative 24 so that the sum gives you 2. And set t plus 6 equal to 0, we get t equals negative 6. And set t minus 4 equal to 0, we get t equals 4. So now this just gives us t. We really need to figure out what x is. So we go back up here, and I'll change my colors. So we have this equation for t. T is equal to x squared. So now we're going to take what t is, it's x squared, and we're going to replace these t's with x squared. So you're going to do the same thing right here. Replace that with an x squared. So we get x squared equals negative 6, and here we get x squared is equal to 4. So then to finish solving these, we would have to take the square root on both sides, and that gives me x is equal to plus or minus. We have the square root of negative 6, so that's going to be I times, oops, sorry, I forgot my plus or minus. Plus or minus I times the square root of 6. Taking the square root on both sides of this one gives us plus or minus 2. So again, we have four solutions because we have a fourth degree polynomial. Positive I times the square root of 6, negative I times the square root of 6, positive 2, and negative 2. So again, we could have just factored this polynomial right away. Normally when we factor, we would write x and a number. But because this is x to the fourth and x squared, you're always just going to use the middle term when you do your factoring. So this would be x squared plus 6 and x squared minus 4, instead of x plus 6 and x minus 4. And then x squared plus 6 equals 0, you would get x squared equals negative 6, and then when you take the square root on both sides, you get exactly what we got up above. X equals plus or minus I times the square root of 6. Same with this one, set x squared minus 4 equal to 0. You get x squared equals 4, and then when you take the squared on both sides, you get that plus or minus 2 as your other two solutions. So again, you can do it either way. So you can either do the substitution method that I did first, or you can just go ahead and factor, whichever way you're more comfortable with. So here's our next example. We have 2x to the fourth minus 13x squared minus 45 equals 0. So again, you can do the same thing that we did in the last example. You can either do the t substitution thing, or you can factor it. So I'll do the substitution way. So t is equal to x squared. That would give me t squared equals x to the fourth. And then when we take this x to the fourth is equal to t squared, so I'm going to replace that that x to the fourth with t squared. So we get 2t squared minus 13, and x squared is t, so I'm going to replace that with t minus 45 equals 0. So we want to see if this factors. 2 times negative 45. So we take this number, the number in front of t squared, times the plain old number, and we get negative 90. Can I factor negative 90 so that the sum of that will give me negative 13? So we would have, what, 9 and 10. That won't work. What if we did 18 and 5? That one will do it. So a negative 18 and 5. So this multiplies together to give me negative 80. And it adds together to give me negative 13. So when I'm doing FOIL, so I need to factor 45, so when I do FOIL on here, I get a negative 18 and a positive 5. So I'm going to want to put a 5 here and a 9 here. So 5 times 9 is 45. And when I do FOIL, I'm going to get 18t here and 5t here. So I want my 18 to be negative, so that's going to be minus, and that's going to be plus. Okay, so now we would set these two equal to 0. 2t plus 5 equals 0. Subtract 5, we get 2t equals negative 5, and then divide by 2. We get t is equal to negative 5 halves. And then t minus 9 equals 0 is going to give us t equals 9. So again, now this is t. I need to figure out what x is. So I go up to my t equals x squared equation. I need to replace these t's with x squareds. This is really important to remember to do this step. So x squared equals negative 5 halves. And then we would take the square root on both sides. And that gives me x is equal to plus or minus the square root of negative 5 halves. And we need to fix the way that we have that written there. It would be plus or minus I times the square root of 5. Oops, keep forgetting to write my I. Over the square root of 2. And we don't like to leave square roots in our denominator, so I need to rationalize my denominator. And so I get plus or minus I times the square root of 10 over 2. And then here, replace this t with x squared. We get x squared equals 9. And then take the square root on both sides. And we get x is equal to plus or minus 3. So there's the other two solutions for that one. And again, you could have just factored this right away. We already have it factored here. So instead of these t's, you would have x squared. So it would factor as 2x squared plus 5 times x squared minus 9. And then you would set these two equal to 0, and you would end up getting the same result that we got. In our next one, we have x to the negative second minus x to the negative first equals 6. Before you begin solving these, you want to make sure you have everything all on the same side of the equation. So we'll have x to the negative second minus x to the negative first minus 6 equals 0. And so we're going to do the same thing that we've done before. I'm going to let t be equal to, always pick this middle one, so that would be x to the negative first, and then t squared. If you take x to the negative first times x to the negative first, you would get x to the negative second, as you add exponents, and negative 1 plus negative 1 is negative 2. So this term is going to become t, and this term, or t squared, sorry, and this term becomes t. So we get t squared minus t minus 6 equals 0. This factors. Factor negative 6 so that the sum gives you negative 1. That would be t minus 3 times t plus 2. So when we set t minus 3 equal to 0, we get t equals 3. And when we set t plus 2 equal to 0, we get t equals negative 2. So again, don't forget this last important step, and that's to replace the t with whatever it's equal to, and this time it's equal to x to the negative first. So we get x to the negative first is equal to 3. X to the negative first is the same as 1 over x. And so if basically you can do this. 1 over x equals 3 over 1, and then you can just cross multiply. And that would give you 3x equals 1, and then divide by 3. And so you get x is equal to 1/3. And do the same thing here. This is t. We need to figure out what x is. So it's x to the negative first equals negative 2. And you can think of that as negative 2 over 1. And x to the negative first is 1 over x. And then you would cross multiply, giving you negative 2x equals 1, and then divide by negative 2. And so we get x is equal to negative 1/2. In our next example, 3x to the 2/3 minus 2x to the 1/3 minus 8 equals 0. So again, t is always going to be the variable that's right in the middle, so that's going to be x to the 1/3. So then t squared is going to be x to the 2/3. So this would get rewritten as 3t squared is x to the 2/3, so that would be 3t squared minus 2, and x is equal to x, or t is equal to x to the 1/3, so it would be minus 2t, and then minus 8. Now we can factor this. So it's going to be 3t, and this is going to be t. That's the only way to factor 3t squared. So now we just need to know how, are we going to factor negative 8 as a combination of 1 and 8, or 2 and 4? So one thing that I like to do when I'm doing these is just to take the constant, or the number in front of x squared and the constant term. So 3 times negative 8 gives me negative 24. And then factor negative 24 so that the sum gives you negative 2. And that's negative 6 and positive 4. And so when I do FOIL, I need to end up with these two numbers, negative 6 and positive 4. And I need to do it with a 3t and a 1t. And so that tells me how I have to factor this 8. So I'm going to need to factor it as 2 times 4. And I need to end up with a 6 and a 4. So when I do FOIL, I'm going to put my 2 there so that I get my 6t. And then when I multiply these two together, that's where I'm going to put my 4 so that I get 4t there. We wanted a negative 6t, so that means that I need to put a minus sign there so that I get negative 6t when I multiply there, and a positive there. So then just double check to make sure that everything works. You have 4 times negative 2 is going to give you the negative 8 you need. This is going to give you a positive 4t. This gives you the negative 6t. So that's going to give you the negative 2 in the middle. And then you have 3t times t, which is the t squared. So you just need to make sure that you double check to make sure that you have your factoring done correctly. So now take 3t plus 4 and set it equal to 0. Subtract 4 from both sides. So you get 3t equals negative 4, and then divide by 3. We get t is equal to negative 4/3. And then here, t minus 2 equals 0. Add 2 to both sides, you get t equals 2. t, however, remember, is equal to x to the 1/3. So replace the t with x to the 1/3. X to the 1/3. What you do with exponents when you raise one power to another power is you multiply them. So I want to raise both sides of this to some power. And what you do when you raise this to this power is you multiply. So 1/3 times 3 is going to give me x to the first. So I need to cube both sides. So that'll give me x is equal to negative 4 cubed. Let me just double check that on my calculator. Is 64. And 3 cubed is 27. Do the same thing with the 2. So it's going to be x to the 1/3 equals 2. And so to get this so that it's x to the first, we would have to cube both sides. And so that gives you 8 as the second solution there. Okay, we just have a couple more examples to run through here. Just 2 more. Our first one, 2 plus 5 over 2x minus 1 equals negative 2 over 2x minus 1, the quantity squared. So again, anytime you see any kind of fractions like this in a problem, it's a good idea to get rid of those by multiplying by the least common denominator. And so we have 2x minus 1 here, but we have 2x minus 1 squared here, so the common denominator is going to be 2x minus 1, the quantity squared. So multiply each term in the equation by that. You get 2 times the quantity 2x minus 1 squared plus 5 over 2x minus 1 times 2x minus 1 squared equals negative 2 over 2x minus 1, the quantity squared, times 2x minus 1, the quantity squared. So our first term is just going to be 2 times quantity 2x minus 1 squared. Plus here, this 2x minus 1 cancels with only one of those, so I have plus 5 times the quantity 2x minus 1. And it's equal to, both of these are going to cancel this time, so just negative 2. So I want everything on one side, so I'm going to add that 2 to both sides of this. That'll give me 2 times the quantity, and in fact I'm going to just change this to red. 2x minus 1 squared plus 5 times 2x minus 1, and then plus 2 equals 0. So now you see I have, in red, I have something squared and something not squared, and they're both the same thing. And so we can use that method that we were using before. And so we're going to let t be equal to 2x minus 1 and t squared be equal to 2x minus 1, the quantity squared. So now this would become 2t squared. Oops, we can just change back to black for that. Sometimes having different colors helps visualize things. So now again I have a quadratic, and hopefully I'll be able to factor this. So let's see if we can factor this. 2t and a t. That's the only way to factor 2t squared. And now I have a 2, so either I need to put a 1 there and a 2 there, or the other way around. And so let's see if I get a 5. So here I get t, and here I get 2t. Oops, sorry. 2 and 2 is 4, not 2, so we get 4t, and we can actually make 5t with that, so both of them would be addition. And so luckily for us, this factored. Now we would set 2t plus 1 equal to 0. Subtracting 1 gives me 2t equals negative 1, and then divide by 2, I get t equals negative 1/2. And here set t plus 2 equal to 0 gives me t equals negative 2. So here's what I get for t. Now remember, we need to go back up here and use this. So t is really equal to 2x minus 1. And so it equals negative 1/2. And then we would add 1 to both sides, giving me 2x is equal to positive 1/2, right? Negative 1/2 plus 1 is positive 1/2, and then divide by 2. So we get x is equal to 1/4. This is like dividing by 2 over 1, which is the same as multiplying by 1/2. Do the same thing with the other value we got, which was negative 2. So if we use our colors, that would be 2x minus 1 equals negative 2. So we're going to add 1 to both sides, and we get 2x equals negative 1, and then divide by 2, and we get x is equal to negative 1/2. So there are 2 solutions for this problem. And this last one is already, it's just like the one that we just did. So we already have it written in this form. And so we're going to do exactly the same thing that we did before. So we have this quantity being squared here, and this same quantity not being squared here. And so t is going to be equal to 3x minus 4, and t squared will be the quantity 3x minus 4 squared. And so this will become t squared minus 9. Oops, I don't need parentheses because this is, I'm going to replace with t and then plus 18. And we can actually factor this. We can factor 18, so the sum gives us negative 9. It would be minus 3 and minus 6. So t minus 3 equals 0 is going to give me t equals 3, and t minus 6 equals 0 gives me t equals 6. So now we need to replace the t with 3x minus 4. So that's 3x minus 4 equals 3. Add the 4 to both sides, and we get 3x equals 7, and then divide by 3. So we get x is equal to 7/3. Here, we're going to let 3x minus, oops, not writing everything. 3x minus 4 equals 6. Add the 4. We get 3x equals 10, and then divide by 3. And so the other solution is 10/3. Okay, and that's all we have for this lecture. Let me know if you have any questions. Thanks.